Hello, welcome viewers. Let's start our topic. We were discussing about the solution of the linear algebraic equation. Linear algebraic equations, it may be in 2 variable, 3 variable or 4 variables. There are many methods to solve the system of the equation. Last time we discussed about the Gaussian elimination method. No, we will discuss the modified form of the Gaussian elimination method. It is called the pivotal condensation method or the row interchange. The difference is, first of all, the difference is that in the previous method of the Gauss, we were not allowed to interchange the rows, but in this method, in the pivotal condensation method, we are allowed to change, or we can change or interchange the rows, but under certain conditions. And what are the differences? That we will discuss it with an example. Let us consider a system of equations. Say it is 3x2. First of all, say it's pivotal condensation method. Pivotal condensation method or Gaussian elimination method or Gaussian elimination method with row interchange. Here we can interchange the rows among them under the certain condition. So please be careful between this method and the method previous. That was a simple Gaussian elimination method. Both are different methods. Let us try to solve this system of equations. Say it is 3x2 plus 4x3 is equal to 2. That is 4x1 minus 2x2 plus x3 is equal to 18. Then 3x1 plus 4x2 plus x3 is equal to 11. It is a given system of the equation where in the first equation x1 is missing, so we complete this term by using 0 into x1. Then x1, x2, x3 and the constants, they are on the one side. We can solve this system even by the simple Gauss elimination method, but here again I say it is the pivotal condensation. What does it mean and what is the difference between this method and the previous methods, and why we prefer this method over that method? Again, the question is that why there are so many methods for the same problem. Again we say we require for the scientific calculations always we require the more exact calculation, and for that we always looking for the better options or the better methods. Again the system is same. First of all we will write it into the matrix form. It is say 0, 3, 4, 2, 3, 4, 1, 11, 4, minus 2, 1 and 18. It is the matrix of coefficients along with signs, and the variable which is missing we denote it by 0. Again the system is same. Now first of all what we see, we check in the first column. We check in the first column that which number is largest. Which number is largest? Here we see 4 is the largest. Check in the first column which integer is largest irrespective of the sign. We don't consider the sign. If it were -4, even we would have taken this 4. We would have considered this 4. Change this 4 with this 0. It means we can follow the rule that R1 interchanges with R3. Here row interchange is allowed, but under the particular condition. But condition we followed in the first column, we check the elements, the largest integer irrespective of the sign. Either it is positive or negative, we have to see only the value of the integer. We interchange that integer with the first row. That is why we are interchanging R1 with R3. Here we can write it in this way: 4 minus 2, 1, 18, 3, 4, 1, 11, 0, 3, 4 and 2. It is the first step. It is the first step. Now we see it is a triangular matrix and these are the diagonal elements. Again, our main objective is to make this matrix, to convert this matrix into the triangular form. We shall convert these 3 elements into 0. 1 is already 0. So first of all, we start with this, then this, then this. Systematically, if we will follow the rule randomly, then it will create the problem and it will create it will generate the inaccurate results. How to dissolve this 3? Again we follow the method which we followed in the simple Gaussian elimination method. Right here we change, say, operation R2 changes to R2 minus 3 by 4 R1. Again this upon this. The element to which we want to dissolve into 0, we keep it into the numerator and with the help of the first row that is in the denominator multiply by R1. Let us see on the rough side what we have done. If we write this matrix with A augmented B matrix, that is equal to matrix, it is 4 minus 2, 1, 18. Let us see here R2 changes to R2. R2 element is 3 minus 3 by 4 into R1 means 4. That is 3 minus 3 is equal to 0. In this way we select our operations. This rule was followed in the simple Gauss elimination method. Then for this element again we calculate 4 minus 3 by 4 into R1 minus 2, that is equal to 4 plus 3 by 2, that is 4 plus 1.5, that is 5.5. Now for third element it is 1. R2 1 minus 3 by 4 into R1 again 1, that is 1 minus 0.75, that is equal to 0.25. That is no. Fourth element, it will also follow the same rule, that is 11. R2 11 minus 3 by 4 into R1. R1 is 18. that we can do 11 minus 27 divided by 2, that is 11 minus 13.5. It is minus 2.5. And third row 0, 3, 4 and 2. These two dots do not represent ratio. It's only the sign to separate the main matrix with the right hand side. In this case, it is already 0, so we need not to change it into the 0. Next step, again, we are following again pivotal condensation. First, the window was 3 by 3. It was a 3 by 3. Now reduce the window into 2 by 2. This is the new window for the matrix. Now, in the first column, for this window, it is the first column. It is the first column, that is this. Again, we look for the larger integer irrespective of the sign. Here it is 5.5 and we interchange them between R2 and R3. Here already 5.5 is at R2 and 3 is at R3. So there is no need to interchange the row. If it would have been like this, 3, 5.5, 0.25 minus 2.5, then we would have changed 5.5 to this and this to this. It is the pivotal condensation. Now we have to reduce this member into the 0. We have to dissolve it by using this. So we follow R3 changes to R3 minus 3 upon 5.5. The number which we have to dissolve, we keep it in the numerator, and with the help of above row, that is in the denominator, into R2. We can again calculate all the values. That is equal to, it is 4 minus 2, 1, 18, 0, 5.5, 0.25, minus 2.5, 0. First of all, we see this element, it is R3, 3 minus 3 upon 5.5 into 5.5, that is equal to 3 minus 3 is equal to 0. And that was our requirement. Then what's about this element? It is 4 minus 3 upon 5.5 into 0.25. That can be calculated. That is 4 minus 0.136. That will come 4 minus 0.1, and we round off it to 0.14. 4 minus 0.14, that is equal to 3.86. 3.86. Now, last element 2. It is 2 minus 3 upon 5.5 into minus 2.5. That is equal to 2 plus 7.5 divided by 5.5. It will come, that is equal to 2 plus 1.36, that is 3.36. No, our objective is solved, our purpose is completed, that this lower triangle has become 0. Now we follow the rule of the re-substitution. From where we started, we will send these equations to the same position. That step we call re-substitute. We can convert this equation. It is 4x1 minus 2x2 plus x3 is equal to 18. Now here x1 is equal to 0, 5.5 x2 plus 0.25 x3 is equal to minus 25, x1 0, x2 0, 3.86, x3 is equal to 3.36. That is number 1, 2 and 3. We can solve them. Here x3 is equal to 3.36 divided by 3.86. That is equal to that is equal to 0.87045. We have to consider the result minimum up to 4 decimal place. Now we put this value x3 in number 2. From 2, what we get? 5.5 x2 plus 0.25 into 0.8705 is equal to minus 25. That 5.5 x2 is equal to minus 25 minus that is 0.2176. That is equal to minus 25.2176 divided by 5.5, that is equal to x2. That's equal to 4.59. And if we put the values of x2 and x3 in number 1, we will get x1. Here from 1 we get 4x1 minus 2 times of x2. x2 means 4.59 plus x3 and x3 is equal to 0.8705 is equal to 18. That is 4x1 plus 9.18 plus 0.8705 is equal to 18. Then we say 4x1 is equal to 7.9495. So x1 is equal to 7.9495 divided by 4. That is equal to 1.9874. Now in this way we calculate the system of equations, linear equations. There may be 3 variables, there may be 4 variables. If the variables are 4, equations will be 4. This is the pivotal condensation method. So we must always keep in mind while solving the system that what is the requirement. Either it is the Gaussian elimination method with row interchanging or without row interchanging. Both have the differences, but the objective for the both the functions is same. These are the methods which we have discussed. These are also called the direct methods. Direct methods to solve the linear algebraic equations. Now we shall discuss the most typical formation in the direct method, that is the LU decomposition method. That's the problem with this method is it requires a lot of working. It requires a lot of working and number of steps. Even it is in the 3 variables. So it requires more patience than the concentration. Patience are must. It's a very lengthy process. It requires a more working. That is LU decomposition. LU decomposition means lower triangular and upper triangular matrix method. What we do, we split the given matrix of the system of the equations into the lower triangular matrix and the upper triangular matrix, and then we continue our process until we calculate our variables. Let's start with this. That is called LU decomposition. LU decomposition method. It is also direct method. Third, we are discussing the third method in the directs. That is solve the system. Again, the formation is the same. Solve the system of the equations by using LU decomposition method. Let us consider this equation system. It is, say, 2x plus 3y plus z is equal to 9 and x plus 2y plus 3z is equal to 6, 3x plus y plus 2z is equal to 8. That we see again the system is same which we are discussing, but now the method is different. LU decomposition method. So in spite of discussing its theory in the detail, with the help of an example we can understand this method more simply and more easily. We are going to divide it into the different steps. First step we start, we write A is equal to L into U. A is the matrix of the coefficients of this system, L is the lower triangular matrix, and U is the upper triangular matrix with the condition UII is equal to 1. UII means diagonal elements of the upper triangular matrix, they should be all 1. So we split this, say that is the lower triangular matrix, it is L11 0 0, L21 L22 0, L31 L32 and L33. It is a lower triangular matrix. How? All the elements above this diagonal are 0. And what's about this? L1, 1, 2, 3, 4, 5, 6. They are the unknown constants. We have to find the value of this constant. Then what's about U? U is the upper triangular matrix with the condition each diagonal matrix that must be equal to 1. First element 1, U12, first row, second column, first row, third column, then it's 0, diagonal element 1 and U2, 3, second row, third column, it's 0 and it's 1. And what is the given matrix? That is the matrix of the coefficients. It is 2, 3, 1, 1, 2, 3, 3, 1. That is the first step. We decompose the matrix of the coefficients of the given system into the lower and the upper triangular matrix. Then our main objective is, in the first step, we have to find all these 1, 2, 3, 4, 5, 6, 7, 8, 9. These 9 constants, values of these 9 constants. We will follow the simple multiplication rule of the matrices. We can multiply these two matrices, its row by column. That is, first row with first column. It will become L11 0 0 0. Then first row, second column. It is L11 U12 0 0 into 0 0. Then L11 U13 first row, third column. This into this into this 0 and this into this 0. After that we pick up the second row with first column L2 1, this into this 0, this into this 0. Then second column L21 U12 plus L22 and 0 into 0 0. Then third row, third column, it is L21 U13 plus L22 U23 and this into this 0. Then third row, third column, this into this, that is L3 1, this into this 0, this into this 0. Then L3 1 U12 plus L3 2 and this into this 0. Last element L31 U13 plus L32 U23 plus L33. That is the multiplication of the left side. That is equal to 2 3 1 1 2 3 3 1 2. That's what we have done. Simply we followed the rule of the multiplication of the two matrices. We multiplied it and it is the new matrix. Now here again we follow the basic rules of the matrices. We know the two matrices are equal if their corresponding elements are equal. It means from here we can find out, say, that is L11 is equal to 2, L21 that is equal to 1, and L31 that is equal to 3. This is equal to 3. Then out of the 9 constants, 3 constants are directly available. Now with the help of these 3 we can find the others also. Let us come now. This element, say L11 U12 is equal to, that is equal to 3. Here put the value of L11, that is 2 into U12 is equal to 3. Then U12 is equal to 3 by 2. For this element, no, L11 U13 is equal to, that is equal to 1. Corresponding elements, that is here L11 is equal to 2 into U13 is equal to 1, then U13 is equal to 1 by 2. So, from the second row, here is the element, it is L21 U12 plus L22 is equal to, this is equal to 2. Put the values which we have already. L21 1, U12 3 by 2, plus L22 still unknown, that is equal to 2. Then L22 is equal to 2 minus 3 by 2, that is equal to 1 by 2. After that we take this equation, L21 U13 plus L22 U23, this element is equal to 3, and put the available values for this. U21, that is equal to 1 into U13 into 1 by 2 plus L22, 1 by 2 into U23 is equal to 3. Half of U23 is equal to 3 minus 1 by 2, that is equal to 5 by 2. Therefore, U23 is equal to 5. Next, we are left with this equation, L31 U12 plus L32 is equal to 1. Substitute the given values or already calculated. L31 3 U12 into 3 by 2 plus L32 is equal to 1. Then L32 is equal to 1 minus 9 by 2, that is equal to minus 7 by 2. We have the last equation, it is L31 U13 and plus L32 U23 plus L33 is equal to last element, that is equal to 2. Substitute the already calculated values, that is L31 here it is 3 into U13 1 by 2 plus L32 minus 7 by 2 into U23, that is into 5 plus L33 still unknown, and that's equal to 2. That is 3 by 2 minus 35 divided by 2 plus L33 is equal to 2. Then L33 is equal to 2 minus 3 by 2 plus 35 by 2. That's equal to 36 divided by 2, and that is equal to 18. In this way, we find all the 9 unknown constants by using the basic concepts of the matrices. That was the first step. Split the given matrix into the lower and the upper triangular matrix. Then we find the unknown constants which we introduce into the first step. From the second step, that is these values, we substitute in the given matrices, that is here L is equal to, if we separately write it, L is equal to, that was L11, it is 2, 0, 0, then L21, L11, L12, L13, then L21, 1, then L22, that is 1 by 2, and L23, that is equal to 0. Then L31, 3, L32 minus 7 by 2, and L33, that is equal to 18. It is lower triangular matrix, and U upper triangular matrix, that is equal to U11 first element 1, then U12 3 by 2, U13 1 by 2, it's 0, it's 1, then U23 that is equal to 5, 0, 0 and 1. Now our first step is complete. We have calculated L and U in terms of the integers. Now we start with the second step by using these two matrices L and U. Second step, we consider L into Y is equal to B. Who is Y? Y is the another column matrix which we introduce, and B is the column matrix on the right hand side of the given system of the equations. That is L into Y means it is 2, 1, 3, 0, 1 by 2, minus 7 by 2, 0, 0, 18 and Y we consider say it is Y1, Y2, Y3 is equal to B. B is the column matrix of right hand side. It was 9, 6 and 8. Now we can calculate this system for Y1, Y2 and Y3. Again we follow the multiplication rule, that is 2y1 this into this 0, 0, 0, 2y1 is equal to 9, then y1 plus half of y2 is equal to 6, 3 times of y1 minus 7 by 2 y2 plus 18 y3 is equal to 8. First row, first column, second row, second column, third row, third column. From here we get y1 is equal to 9 by 2. That is step number 1 and it is number 2. We say from 1 we get, it is y1 is 9 by 2 plus 1 by 2 into y2 is equal to 6. Then half of y2 is equal to 6 minus 9 by 2, that is equal to 3 by 2. It means y2 is equal to 3. Then from 2 3y1 means 3 into 9 by 2 minus 7 by 2 into y2 means 3 plus 18y3 is equal to 8. That is 18y3 is equal to 8 minus 27 divided by 2 minus plus, that is 21 divided by 2 to 16 minus 27 plus 28, that is equal to 32 divided by 2. That is equal to 16. That is equal to 16. Therefore, y3 is equal to 16 by 18. That is 2, 8, 16, 2, 9, 18. That is equal to 8 by 9. Now we have find out y1, y2 and y3. With this help of y1, y2, y3, we will conclude our result. Now it is the third step. Say now third step starts u into x is equal to y. U is the upper triangular matrix, x is our requirement x, y, z, and y that we calculated in the previous step. So u is equal to 1, 3 by 2, 1 by 2, 0, 1, 5, 0, 0, 1, and x is variables were x, y, z is equal to y1, y2, y3. That is y1 9 by 2, y2 3 and 8 by 9. That is equal to, then we will have to make some correction. 10 divided by 2, that is equal to 5, and here y3 is equal to 5 by 18. y3 is equal to 5 by 18. So this is the final step. Third step, we can calculate it for x and y. Again, by using matrix multiplication, it will give x plus 3 by 2y plus 1 by 2z is equal to 9 by 2 y plus 5z, x is 0, this is y, z is equal to 3 and z is equal to 5 by 18. x0, y0, this into this, z is equal to 5 by 18. That is number 1. Number 3, and it is number 4. So put here, put in 4, we get y plus 5 into 5 by 18 is equal to 3, and then y is equal to 3 minus 25 divided by 18, that is equal to 54 minus 25 divided by 18, that is equal to 29 divided by 18. And we put these values in number 1, that is from 1 x plus 3 by 2 into 29 by 18 plus half of z into 5 by 18, that is equal to 5 by, that is equal to 9 by 2. X plus 87 divided by 36 plus 5 divided by 36 is equal to 9 by 2. So x is equal to 9 by 2 minus 87 by 36 minus 5 by 36. And we can solve it. 117 minus 87 minus 5. That is equal to 25 divided by 30. So that is the calculation for the LU decomposition method. Its working requirement is very hard. It requires patience as well as concentration. Here we consider the 3 variables. It can be also in the 2 variables. The methods we discussed, they were the direct method. Now we concentrate on the indirect methods. In the indirect methods, we follow the scheme of the iterations, or we call them the iterative scheme. Repeat the step again and again to get the more and more accurate results. In this section, we shall discuss Jacobi's method or Jacobi's iterative method, and second, Jacobi and Seidel iterative methods. Both are approximately same. There are only difference in some substitution of the values, and that we will understand only during the calculations. Now first of all, we shall discuss in the indirect method. Now we are going to discuss indirect methods to solve the linear algebraic equations. In this method, we first of all discuss Jacobi's method. Again, our objectives is same. Solve the following system of the equations, or sometimes we also call it Gauss-Jacobi's method. Gauss-Jacobi method, iterative method. Let us see, solve the system of the equation. It is minus 4x1 plus x2 plus 10x3 is equal to 21, 5x1 minus x2 plus x3 is equal to 14, 2x1 plus 8x2 minus x3 is equal to minus 7. There is no difference. Again the system is same. We can solve the system or with the methods already we discussed, but with the help of this method, what are the procedures, what are the steps that we are going to discuss. The first step, keep in mind that here we write the coefficients in the form of a matrix 4, 10, 5, minus 1, 1, 2, 8 and minus 1. It's a rough work. Simply we write the elements of coefficients of the elements along with the sign. That's our purpose is that we want A33 must be greater than A22 or A22 must be greater than A11. It is A11, A22, A33. It means diagonal elements. The diagonal elements should be in the increasing order. We have to reshuffle these equations in such a way. So we see it is not in the proper order. We want 5. Here we can write 5 minus 1, 1. Then in first column see the largest element 5. Write it here. In the second column largest element is 8. After that 2, 8, minus 1. In the third column see largest element is 10. We write this equation, that is minus 4, 1 and 10. Now we can see this diagonal elements, they are following this rule. A33 or we can say A11 is less than A22 and A22 is less than A33, or we can say A33 is greater than A22 and A22 is greater than A11. In this way, we reshuffle the given system of the equations. If it is already in the proper order, then there is no need. Here we will have to reshuffle the equation. No. First we will write here 5x1 minus x2 plus x3 is equal to 14 according to this line. Then second it is 2x1 plus 8x2 minus x3 is equal to minus 7. Third one start with this. Minus 4x1 plus x2 plus 10x3 is equal to 21. It is the first step. 1, 2 and 3. First step is arrange the reshuffle the given system in such a manner that its diagonal elements follow this rule. If it is already, then there is no need to reshuffle them. Then secondly, we can solve them like this. From equation 1, we find value of x1. 1 implies x1 is equal to 1 by 5 into 14 minus x3 plus x2. We can solve it simple algebra. Then From second equation we find x2. From first equation we calculate x1. From second equation we calculate x2, that is equal to 1 by 8 into minus 7 minus 2x1 plus x3. And from the third equation we calculate x3. x3, that is equal to 1 by 10 into 21 plus 4x1 minus x2. That is why in the first step we reshuffle the equations, because from the first equation we find x1, from second x2, and from third x3 or xy z. Now this system, say it is 4, 5 and 6. Now we have this system. We start the iterations now. Take initial values like this for x1, x2, x3 is equal to 0, 0, 0. Always we start with 0, 0, 0. We consider the initial values 0, 0, 0, or if it is given in the problem, take the initial values, say 1, 2, 3, we shall start with the given values. Otherwise, we will always start our iteration scheme with the help of this method, initial values taking 0, 0, 0. Then from 4, put in 4, from 4 we get x1 is equal to 1 by 5 into 14 minus x3, 0, x2, 0. That is equal to 14 upon 5. That's equal to 2.8. Now from 5 we get x2. That is equal to 1 by 8 minus 7 minus 0 plus 0, because initial values are 0, 0, or otherwise, again I repeat, if it is provided, take the initial values, say 1, 2, 3, 0.1, 0.1, 0.1, whatever he says, we can start with that. Otherwise, we consider this 0, 0, 0. That's equal to minus 7 by 8. That is equal to 8.88. Then from 6 it is x3. That is equal to 1 by 10 into 21 plus 0 plus 0 is equal to 21 divided by 10, that is equal to 2.1. It is 0.88. No, it is the first step. It is the first iteration complete, and we represent it in this way: x1, x2, x3. We write first. It means first scheme is complete, and the value is 4x1, it is 2.8, and 4x2, it is minus 0.88, and 4x3, it is 2.1. That is the first step. Now we start the second step with these values. Second step means second iteration with these values. Again from 4, we consider these values which we got in the first iteration, that is this. It is x1 is equal to 1 by 5 into 14 minus, what is x3? 2.1 plus x2, it is minus 0.88. that is equal to 2.204. From 5 we get x2 is equal to 1 by 8 minus 7 minus 2 into x1 2.8 plus x3 2.1. That is x2 is equal to 1 by 8 minus 7 minus 5.6 plus 2.1. We can calculate it. That is equal to minus 1.313. From 6 x3 is equal to 1 by 10 into 21 plus 4 times x1. x1 is 2.8 minus x2. Minus plus, that is 0.88. That's equal to 3.308. It is the second iteration, and we got the values here x1, x2, x3. We represent it like this: x2, x2, 2. It indicates that these values are generated in due to the second iterations. That is 2.204 minus 1.313 and 3.308. Second step is complete. In this way, we continue our process. In the next step, in the third iteration, we will consider these values, and we will complete the third iteration, then fourth, then 5, then 6. But up to when? Up to that step when the two conjective values, either they are equal or repeat itself, or they are approximately equal. It may be after 5 steps, maybe after 10 steps, maybe after 25 steps, but for the exam point of view, we can follow only 3 steps, maximum 3 steps, first, second, and you can do one more step for this. That is a Gauss-Jacobi method. It's a simple method, iterative method, or we say it is an indirect method. In the indirect method, second method, that is Seidel method, that's the important one, and that result are in the Seidel method, they are more accurate and more fast than in the Gauss-Jacobi's method. Again, the objective is same. We say it is Gauss-Seidel method. Both methods are approximately same. But what is the difference? It is a minor difference, but that is a most important one. Let us see or consider the system of the equations. That is 10x1 minus x2 plus 2x3 plus 0 into x4 is equal to 6. And if x4 is missing, it was missing, we can write it in the form 0 into x4. minus x1 plus 11x2 minus x3 plus 3x4 is equal to 25. Then 2x1 minus x2 plus 10x3 minus x4 is equal to minus 11. 0 into x1 plus 3x2 y0. It was absent here, so we can represent it like in this way: minus x3 plus 8x4 is equal to 15. Again we have the system. This time we have 4 variables and the 4 equations. They may be 3. How to solve them? Again, first step is the same. First step is same means we follow the rule. See, these are the diagonal elements. Say it is 10, 11, 'So we keep the system as it is given. Now, from equation number 1, say it is 1, it is 2, it is 3, and it is 4. From 1, we calculate x1. x1 is equal to 1 by 10 into 6 plus x2 minus 2x3. Take it number 5. Then from 2 we calculate x2 is equal to 1 by 11. These coefficients, they are always outside the bracket in the denominator. That I have marked them 1 by 11. x2, that is 25 plus x1 plus x3 minus 3x4, take it number 6. And from third equation we get x3 is equal to 1 by 10, this element, minus 11 minus 2x1 plus x2 plus x4, say it is number 7. From 4 we get x4 is equal to, here is 1 by 8, that is 15 minus 3x2 plus x3, and it is equation number 8. Again, up to this step, both methods are common. From first equation we calculate x1, x2, x3 and x4. In this method, we didn't follow the rule of the diagonal elements. No, we start always, again, take initial values that are x1, x2, x3, x4 is equal to 0, 0, 0, 0. Take the initial value 0, 0, 0 always, or otherwise whatever the values are provided. Say it is 1, 2, 3, 4, we shall start with 1, 2, 3, 4 or whatever is given in the problem. If it is not given, then we always consider the starting values 0, 0, 0. Where now we shall put these values in equations this. Again, the step is same. Say equation 5. From equation 5, we calculate x1 is equal to 1 by 10 into 6 plus 0 minus 0, that is equal to 6 by 10, that is equal to 0.6. Up to this step, there is no difference between the Gauss-Jacobi and the Gauss-Seidel method. No. After this step, the difference starts. See, it is the new value of x1. It is the new value of x1. Now, from 6 we calculate x2. From 6 we calculate x2 is equal to 1 by 11 into 25 plus, see, here it is x1, but we will not take x1 0 as we used it in the Gauss-Jacobi method. Here we consider the value of x1 which is calculated in this step, that is 0.6. That is the difference. In the Gauss-Seidel, we use the new calculated value in the same step, but in the Gauss-Jacobi, we use the values in the next step. That is why this method is more accurate and the more fast than the Gauss-Jacobi method. So here we have considered x1 is 0.6 plus x3 0 minus x4, that is 0, that is equal to 25.6 divided by 11, that is equal to 2.33. Round of them. Then see, from equation number 7 we get x3. x3 is equal to 1 by 10. So see, it is the new value. It is the new value of x2. So x3 is equal to 1 by 10 into bracket minus 11 minus 2 times of x1. 2 times of x1. Here we use the value, new value of x1, that is 0.6 plus x2. x2, again we use the new value, that is 2.33 plus x4. For x4 we take, it is 0. That is the difference between the Jacobi and Seidel. Now we calculate it, that is equal to 1 by 10 into minus 11 minus 1.2 plus 2.33, and that's equal to 0.99. We are rounding off the values up to decimal 2 place, that's minus 0.99. Now from 8th step we get x4 is equal to 1 by 8 into 15 minus, here it is x2 minus 3 times into x2. We use the value of the x2 here, new value, that is 2.33 plus x3. Here is x3. For x3 we use again new value, it is minus 0.99, and now we calculate it, that is equal to 1 by 8 into 15 minus 6.99 minus 0.99, that is equal to 0.88, that is equal to 0.8. And in the same manner we repeat the second step. Now what are the values of the first iteration? So we write here, that is, say x1, x2, x3 and x4. We represent first. It means first iteration. That's equal to 0.6, 2.33 minus 0.99 and 0.88. In the same manner, we proceed for the second iteration. By using all the values of the new step in the second step. That is the basic equations are same. No, we consider these new values which we find out in the first iterations. Let us start again from number 5. Say 5. Put these values. X1 is equal to 1 by 10 into 6 plus 2.33 minus 2 times of x3 minus 0.99, and that's come to be 0.64, approximately 0.64. Then from equation 6 we get x2. Here it is the new value for x1. It is a new value for x1. When we are going to calculate x2, we will keep it in mind that we have to use this new value of the x1. That is 25 plus x1. We use this value, that is 0.64, not this one, plus x3. Again x3 minus 0.99 minus 3 times of x4, it is 0.88. That is equal to 1 by 11 into 25.64 minus 0.99 minus 2.64, and that is equal to 2 approximately 2. Then for x3, again we keep in mind these two new values which we calculated in the same step. For x3, that is equal to 1 by 10 into minus 11 minus 2 times of x1, it is 0.64 plus x2. For x2, this is the value 2 plus 2 plus x4, that is 0.88. It means we are using the new values in the same step which we are calculating simultaneously. So here that is equal to 1 by 10 into minus 11 minus 1.28 plus 2 plus 0.88, that is equal to that is equal to minus 0.94. Then for x4, we keep in mind these three new values. x4 is equal to 1 by 8 into 15 minus 3 times x2. Here x2 is 2 plus x3. x3 means minus 0.94. That's equal to 1 by 8 into 15 minus 6 minus 0.94. That is equal to 1.0068. So second iteration x1, x2, x3, x4 2 is equal to 0.64. It is 2 minus 0.94, 1.008. And we can proceed the further steps again up to that situation when the two values either approximately or equal or they repeat themselves. It is the Gauss-Seidel method. There is the difference between the both, which I marked with the red circles, and it is the main difference between both the methods. As far as the first step of the diagonal is concerned, that is not necessary in the Seidel method. That we follow only in the Gauss-Jacobi method. That's about the solution of the linear algebraic equations we have discussed up to this now. There are two types of the methods, direct methods and the indirect methods. In the direct methods, we discussed the system of the equations in the different manners, say Gauss elimination method, Gauss elimination method with row interchanging, or we say pivotal condensation method. Then it is LU decomposition method. Fourth, the Cramer rule we also consider in this method, but that belongs to the very basic classes. And in the indirect method, we see there are the two main methods. They are iterative methods. In the indirect methods, they are Gauss-Jacobi method and the Gauss-Seidel method. All the methods are important from the exam's points of view. That is up for this chapter. Any questions, viewers, regarding this lecture? No query? It's okay. Thank you and good day, viewers.